Hello everyone. Let's start a new questions. What is resolutions and pixels in image? Explain different resolutions with their significance. A resolution is defined as a measure of the ability of an optical system or sensors is distinguish between signals that are spatially near or spatially similar. There are four sensor resolutions. First is a spatial resolution, second is a spectral resolutions, third is a temporal resolution, and fourth is a radiometric resolutions. Spectral resolutions. The minimum detected area on ground by detector placed on a sensor is called a spectral resolutions. It refers to capability of sensors to discriminate the smallest object on the ground of different sizes, usually specified in terms of linear dimensions. Images where only large features are available are said to have a coarse or large resolutions. Fine or higher resolution images makes possible detections of small objects. As a rule, higher the resolution, smaller the object that can be identified through spectral resolutions. Spectral resolutions of passive sensors depending primarily on their instantaneous field or a view IFOV. The IFOV may be defined as the area on the ground which is viewed by a single instrument from a given altitude at any given instance of time. This area on a ground is called the resolution cell and determines a sensor's maximum spectral resolutions. The IFOV may also be defined as a angular cone of visibility of a sensor and determines the area on the Earth's surface, which is seen from a given altitude at any given instance of time. Spatial resolutions can be determined using the following formulas. A is equal to HP, where A is the ground dimensions of the detector element in meter, H is the flying height of the platform in meter, and B the IOV in uh, milliradians. milliradians. The spectral resolution of various satellites. There is a satellite's lens. There is a sensor have MSS which give resolutions of 80 meter and TM which gives a sensor of 30 meter. There is Indian based satellite IRS 1A and B. There is two sensors, LIS 1 and LIS 2. LIS 1 gives 72.5 meter and LIS 2 gives a 36.25 meter resolutions. IRS 1CB which have a sensor called PAN, which give a resolution of 5.8 meter. So this is more accurate. IRS 1C or D. Pixel size and scales. Most remote sensing images are compared of pixels, which are the smallest unit of the image. Image pixels are normally square and represent a certain area of an image. It is important to distinguish between pixel size and spectral resolutions. They are not interchangeable. If a sensor has a spectral resolution of 20 meter and an image from the sensor is displays at a full resolutions, each pixel represents an area of 20 meter to 20 meter on the ground. In this case, the pixel size and resolutions are the same. The ratio of distance on an image or map to be actual ground distance is referred to as a scale in a map with a scale of 1 to 1 lakh. An object of 1 centimeter length on a map would actually be 1 lakh centimeter, which is 1 kilometer longer object on the ground. Maps or images with a smaller map to ground ratios are referred to a small scale, and those with a larger ratios are called large scales. Next is the spectral resolutions. Spectral resolution refers to the electromagnetic radiation waves to which a remote sensing system is sensitive. Spectral refers to the number of the width of the segments or bands of the electromagnetic spectrum which are covered by a sensing system. Standard black and white photography, for example, covers the range of visible lights, zero point 0.4 to zero point 0.7 micrometer wavelengths in one band and therefore has a relatively poor spectral resolutions. color photography, which consists of three layers emulsions, effectively splits the same range of wavelengths into three spectral bands such as blue, uh, zero point 0.4 to zero point 0.5 micron, green 0.5 to zero point 0.6 micron, and red 0.6 to 0.7 micron. Spectral resolution describes the ability of sensors to define fine wavelength intervals. The finer the spectral resolution, the narrower the wavelength range for a particular channel of bands. A higher spectral resolution is achieved from a large number of bands and narrow bands width of each bands. By increasing the spectral resolution of the system, the potential of the system is discriminate between features is improved. Features may have a rather similar reflectance over a broad band may differ in detail if a spectral intervals of a sensing is narrowed. The use of several bands of a spectrum is conjunctions is referred to as a multispectral sensing. Third is a temporal resolutions. The temporal resolution refers to the frequency with which a given area is imaged. It is expressed in days and it is also called receptivity. Lower temporal resolutions refers to platform that uh, infrequently repeats coverage, while high temporal resolution refers to a platform that frequently repeats coverages. Temporal resolution refers to the frequency of data collections in remote sensing to capture changes in environmental phenomena occurring. The data may have to be collected either daily, monthly, seasonally, or yearly. For instance, the monitoring crop growth stress or it's a stress or image intervals of 10 days would be required, but intervals of 1 year would be appropriate to monitor urban growth patterns. IRS 1A has 22 days of temporal resolutions, meaning it can acquire image of particular areas in 22 days interval repetitively. Landsat has temporal resolutions of 80 days, while Sport has a 4-day resolutions. This is a temporal resolutions. Fourth is a radiometric resolution. Radiometric resolution refers to the capability of sensors to discriminate two largest based not a largest two targets based on the reflectance or emittance difference. It is measured in terms of smaller reflectance emittance that can be detected by the sensors. Higher the radiometric resolution, smaller the radiance difference that can be collected between two targets. The radiometric resolutions is defined as the sensitivity of the remote sensing detector to difference in single strength as it records the radiation flux reflected or emitted from the terrain. It defines the number of just discriminable signal levels. The radiometric resolutions of an imaging system describes its ability to discriminate very slight difference in energy. The finer the radiometric resolution of a sensor is, the more sensitive it is for detecting small difference in reflected or emitted energy. Okay, so these four are the resolutions. Thank you.